You were thinking way too hard into it.
So today's March 10th, and we are.
I take back what I said.
Simplifying algebraic square roots. And so if you went back in time, like, I don't know, 48 hours, or what's today, Thursday, maybe 72 hours. Whenever it was that we first learned this, you could look at your notes and you would see that, okay, those notes started with simplifying square roots. I added a word today, and the word is algebraic. And do you guys know what's going to change today? No? Well, do you guys know what the term algebraic generally refers to? Honestly, no. No. Here, let me give you an example. Here's a numerical expression. Here's an algebraic expression. Numerical on top, algebraic on bottom implies, yes, that we are now working with variables. And so when you see that term algebraic, it's not 100% like ironclad, but usually what that means is, oh, variables have entered the building. And so that's what's going to change today, is we're going to be doing that same thing where we break down square roots, but the square roots are going to have letters in them. All right. So I'll walk you right through this. If you do as I say and hopefully kind of embrace the method, I don't think you're going to have any difficulty at all. So the way it's going to work is we're going to start by talking about square roots with letters in them, and like, do they work well or do they not work well? And so for our first example, if I put up the square root of x squared, if you're already intimidated, just relax, it's okay. Yes, the answer would just be x, because if you think about it, square rooting is the dead opposite of squaring something. And so square rooting at its core has always been, when I say what's the square root of 4, your brain should instantly go to, oh, he just asked me what number when I square it makes 4, hence the answer 2, right? And so the same thinking leads us to, well, if I want the square root of x squared, it's x that when squared makes x squared. It's almost, you could talk yourself in circles. So what about the square root of x to the 4th? Yeah, it would be x squared, right? And what about the square root of x to the 6th? X to the 3rd. What about the square root of x to the 100th? X to the 50th. Good. And I very purposely did 3 examples before I jumped to the Big Daddy, because I want to make sure you can identify the pattern, that we're not square rooting the 100 to get 10, we're dividing it by 2. And that's how exponents and roots kind of play together, is that when we square root, I feel like you've kind of seen this to some extent when we go the other way, when we learned our rules of exponents. And so, like, look at the exponent and go, oh, I see now, half of 4 is 2. Half of 2 is 1. Half of 6 is 3, and so on and so forth. So are we okay so far? Yeah. So variable values can be square rooted, as you can see, when the exponent is an even number, which begs the question now, of course, well, that solves half my problems. What about when the exponent is odd? And so that's what we'll talk about here for a few minutes, is this, the square root of x to the 5th power. The whole dividing by 2 thing is not going to end well for you, because 5 is not even, and 5 cannot whole number wise be divided by 2. And so here comes, I hope you're listening, and I hope you're ready to just get on board and say, I will do this. We're going to take that square root and we're going to break it into 2 parts. We're going to call it the good part and the bad part. Now, if you think about x to the 5th, it's built from a bunch of, bless you, it's built from a bunch of x's, right? 5 of them to be exact. So what we want to do is we want to break it into 2 parts, such that one of the parts will be square rootable, and then the other part inevitably will be a leftover. And so say that again. Yes, and that's exactly the way we should be thinking, is if I take x to the 5th, I can divvy it into x to the 4th times x to the 1. And that's just good use, Luke, of our properties of exponents. We know that 4 plus 1 makes 5. And we also know that 4 is pretty awesome because it's the biggest even number that I can chunk out of a 5. And as we just learned, what's the square root of x to the 4th? X squared. Good. And so we're going to call this our jailbreak. You've heard me use that term before. X squared is going to break out of jail, leaving his buddy X stuck inside. Easy enough, right? And you can apply this to any buffed up odd exponent. It doesn't matter. Let's say we had like x to the 73rd. It's okay, because all you got to do is think to yourself, okay, what's the biggest even number that I can get to right before I get to 73? So I break it into x to the 72nd times the obligatory leftover x to the 1. And what is the square root of x to the 72nd? X to the, what's half of 72? 36. So we break out of jail, x to the 36th, and he leaves his homie, x stuck in the slammer. Got it? That's how you approach variables when they're odd powers, is you break it into the biggest possible even power with the leftover 1. Now we're going to put this all together into a sort of a package proposal, and our problems are now for the next couple of days of class going to look like this. The square root of 27, x to the 11th, y to the 12th, z to the 35th. So I know it just kind of went like from 0 to 60, but we have now all of the requisite understanding. It's here. We just have to put it all together. So follow these directions real closely, and I think you'll have zero troubles. And this, you're going to want to do this when we do this in Algebra 2. In Algebra 2, when we do this with bigger types of roots, like cube roots and fourth roots, it's really important that you stick to this idea of good guys and bad guys. And so I'll try to keep it color-coded for you throughout the next few minutes. The things that inside we call good guys, I'm going to put little red jelly beans around those, and the leftover guys we're going to just leave uncircled. So let's begin by talking, and this is going to look a little bit different. I don't like making trees with these. I find that they get too ugly. So I'm going to take and I'm going to rewrite this problem, and I'm going to make a longer square root sign because I'm going to need some real estate here, some work space. And we're going to just go and trudge along from left to right. So let's start with what we know about 27. Is he square rootable? Mm-hmm. He is not. The square root of 27 is 5 point something that no one gives a hoot about. But we do know how to break him, right? It's all we've been doing for days. So yeah, and to go a little bit slower, and I appreciate the sentiment of 3 root 3. That's perfect. But to go nice and slow, I'm going to break 27 into 9 times 3. And 9, stick with me here, I'm going to circle, because he, again, is what we'll call a good guy. The good guys, what I mean by that, are they're the things that I intend to square root. Now I'm going to look at those x's. Is x to the 11th a good guy? No, but he contains one. What's the best possible way to break down an x to the 11th? So I'm going to break him into x to the 10th times x. Tell me about y. Is he a good guy? Then don't break him. Just leave him alone. And you can see even with that long square root, I ran out of room. So there's a lot. Are you just jumping ahead to the final answer? I just need to know, are you just trying to just hijack my explanation and just jump to the answer? Because I'm just right in the middle of something here. Oh, sure. Yeah, like you want to write them in a different order than how I'm doing it? Sure, that's fine. Yeah. I just know if I were, listen, we teachers, it's inevitable that we teach the way we would want to be taught. When I explain things to you, I explain them using the words in the order that I would want them to say. I would want someone to say them to me. So if you find alternative sorts of ways to write things in and put them in a different order, more power to you. But for now, I'm going to stick real structured left to right. So let's get back to this. Do we like z to the 35th?
No.
No, but we do know we can make him z to the 34th times z. Now what I'm going to do is I'm going to go back through and I'm going to circle all the good guys. It helps me to see them. So I'm going to say x to the 10th, I made you. You're a good guy. Y to the 12th, you were already a good guy. And z to the 34th, you're a good guy. And the things I haven't circled, like Cooper was talking about, those are the things that invariably are going to have to watch all their friends walk out of jail and be free, right? So at this point now, let's break everybody out. Let's take care of our jailbreaks, and then the non-circled guys can just suck it up. So what does the 9 create? What does the x to the 10th create? What does the y to the 12th create? Y to the 6th. What does the z to the 34th create? Z to the 17th. And then we just simply multiply it all by a root. And the root will always contain the pieces, the fragments that weren't fortunate enough to get broken out of jail. And who's in there? 3xz, and we're done. Okay, let's try like maybe one more example, and then I think I'll just let you work. It's a two-sided worksheet, and that's right, we got more jokes. Did I just? Uh-oh. Yeah, okay, so oops. I'll have to explain something to you. Anyways, that's neither here nor there. Let's try something fancy. Let's do -4 times 162, a to the 20th, b to the 14th, and c to the 21st. Good. All right. So again, if you want to race ahead, you're welcome to. I just would like to not have you do that out loud. So for the sake of anyone who's just kind of feeling like, let's go slow. So we're going to leave -4. And then again, we're always going to take that square root and we're going to rewrite it. And generally we want it to be longer because there's going to be some partitioning that needs to be done. Anyone know 162? You've seen it before. It has come up. 81 and 2. Right, and it helps to work collaboratively. I wish we could take quizzes this way because there's always going to be like good team effort there. But 162 is 81 times 2. Huge to find that. Tell me about A. Do we like him? Yeah, so let's just leave A to the 20. How about the B? Do we like that? Good. I think you guys have got this. What about the C? What do we? 20 and 1. I'm gonna go back through now because I just like stuff like this, and I'm going to circle. You can circle just using a pencil. You don't have to have a red pencil. Just go through and highlight for your brain the things that you intend to break out. Anyone that doesn't get circled, too bad, sucker. You're stuck in jail. So let's begin. What does the 81 create? A 9, which when multiplied by the already broken out of jail -4 makes what? Good job. So we have -36 out and free. How many A's are we going to break out of jail? Nice. How many B's? How many C's? And who's stuck in jail? And that is that. Okay. All right, I'm going to cut this recording off here. Stop that and that.